Okay, picking up where we left off with the getting ready for Unit 1, we're doing number 4. Write an equation for each line. Notice it does not tell me how to write the equation. There are 3 different options that you have for writing an equation. The 3 forms that you're supposed to know. I'm going to write those down real quick. 3 forms for a linear equation. Those 3 forms are y equals mx plus b. What's that called? That's slope-intercept form. Standard form, ax plus by equals c. That's standard form. And then the third one is y minus y1 equals m times x minus x1. That's called point slope form. Point slope. Okay, and this one's called slope-intercept because you know the slope and the y-intercept. This one's called standard form because all the variables on one side. Any kind of equation, anytime all the variables are on one side, it's in standard form. And this one's called point slope form. Why? Because it tells you a slope and a point that the line is passing through. So it doesn't tell us which one. So we could technically write our answer 3 different ways and it'd be right. I'm going to go with the easiest way. They give me a slope and a y-intercept. This is the information right here that they give me. So, of course, I'm going to put it in slope-intercept form. So the answer here would be y equals, just simply put the 3 in the place of the m, 3x plus a negative. I mean, yes, you can write it like that, but that's not considered simplified because by the time you're in Algebra 2, you should not have double signs like that. So we know that plus and a minus is the same thing as y equals 3x minus 2. Adding a negative number is the same thing as subtracting a number. So this would be that answer in slope-intercept form, and that is the most, the fastest, easiest way to do that. So why work harder, work smarter, right? Okay, the next one, they give me 2 points. Anytime they give me 2 points, the very first thing I'm going to have to do is calculate the slope. A lot of students have a hard time remembering what the slope. They don't have a hard time remembering that slope is rise over run. So just remember, if it's rise over run, y's give you rise. So that might help you easier to remember. Then which one is x1, y1, x2, y2? It doesn't matter. Get over here, pick this, call this point 1. If you call this point 1, call it x1, y1. Call this point 2. If that's point 2, call that x2, y2. If you want to call that point 1, you can. That's going to be x1, y1. That'll be x2, y2. It doesn't matter. It's going to work out to be the same. So y2 is 1, the number 1 right there, minus, that's part of the formula, and then 5. We're just plugging numbers in. x2 is negative 4 minus from the formula, and then x1 is 2. Now we follow the rules of combining integers. So a positive 1 and a negative 5. Those signs are different. You subtract and keep the sign of the larger. So that's going to be negative 4. These signs are the same, so you add and keep the sign. So that's negative 6. Now this is division. A negative divided by a negative is going to be a positive. And 4 over 6 will reduce down. I'm going to show why it reduces. Okay. We could even make those 2 2's right there be the negative. So the negative 2 will divide out with the negative 2, and it reduces down to 2 over 3. So the slope of that line is 2 over 3. Now, since we can put the put the equation in any form, because it didn't tell me which form, then I'm going to choose to put it in point slope form. I can go ahead and change it to slope intercept because point slope form, all I need is the slope, which I've just calculated, and a point. Does it matter which one that I pick over here? No. I'm going to pick this one. Why? It has both of the numbers are positives. And positive numbers, I have a tendency to make less mistakes with. So the formula is y minus y1 equals m times x minus x1. And this point right here is the x1, y1. This y and this x stay in the equation, just like this y and this x do. So it's y minus 5 equals 2/3 times x minus 2. And that is an answer. It's in point slope form. If you were going to go over here and graph it, you would graph the point first and then graph the slope. Do rise 2, run 3, and that would get you a graph. But you could also distribute this and then combine like terms. But it didn't tell me that I had to, so I'm not going to. All right, so that was problem number 4. Problem number 5, I'm going to move it over here. It says write an equation for this line. So what do we need in order to write an equation for this line? We need y equals mx plus b. That's what we need. We need a slope and we need a y-intercept. Let me see. Y-intercept, my b is 6. I remember slope face. Slope face goes positive, negative, undefined, 0. Okay, so this line right here is going this way, so I know that my slope is negative. And then I need to pick 2 places where it looks like the line is passing through, you know, the little grid lines right here, passing through it exactly. I mean, there's a ton of points on this line, but I don't want to pick that point right there because where is the location of that point? 2 something, go over 2 and a little bit more, and then go up 4 and a little bit more. No, I want to be able to know exactly where is this point right here? It's over 4, up 3. Where's this point right here? It's over 0, up 6. So this slope right here, to get from this point to this one point, I have to go up 1, 2, 3. I have to rise 3. And then I'm going to run, and since I'm going to the left, I'm going to go negative 1, 2, 3, 4. So I did a negative, rise 3, run 4. And I put the negative sign out in front because I also could say I go down 3 and right 4, and it'd get me to the same slope. So the equation for this line, for number 5, the equation is y equals negative 3/4 x plus 6. I put that in slope-intercept form. If you wanted it in point-slope form, you could have said y minus, I used this point right here, 4, 3. So I could say y minus 3 is equal to negative 3/4 x minus x1. So y minus y1 equals m times x minus x1. I'm sorry, that's so sloppy. But that's the 2 forms. These equations, they look different, but if you were to go to Desmos and type those in the graphing lines, you'd see that it's the exact same line. Okay, number 6 wants to know, do you remember about additive inverse and multiplicative inverse? So as a reminder, additive inverse means if I start with a number, what do I have to add to that number to get to 0? Okay, so most people think, well, you have to add the opposite of that. So if my number is a 5, my additive inverse is going to be negative 5. Because 5 and negative 5 are opposites of each other. They're going to add together to be 0. Multiplicative inverse is if I have a number, what number do I have to multiply it by to get 1? So it's kind of like the opposite, but not really, because we don't want to change the sign. If we change the sign, we'd have a positive number, a negative number, and that would result in negative 1. But we want to flip it upside down. So we want to multiply a times some number would be 1 over a. So the multiplicative inverse for 5 is 1 over 5. So this is the opposite number, and this right here is called the reciprocal. Okay, so the additive inverse is what number do I have to put with this one to make 0? What number do I multiply this one by to get 1? So 5 times 1/5 will give you 1, and 5 plus negative 5 will give you 0. All right, this one they want us to solve it. Well, I cannot solve. Rule number 1 is I must simplify both sides. Simplify both sides. And by simplify, it means combine all like terms. These two right here are simplified. This side right here is simplified. I can't put the 5x together with the 7. But this side over here, I need to distribute that 3. Because when I distribute that 3, it's going to give me 3x plus 6. And then when I put that plus 4 there, I now am going to have like terms that I can combine. So the simplified version of this side is 3x plus 10 is equal to 5x plus 7. Now, because I have a variable on both sides, I need to decide which side I would like my variable on. You either want your variables on the left-hand side or you want your variables on the right-hand side. It doesn't matter. Most people like the variables on the left-hand side. But I'm going to choose to go right-hand side this time because if I move these 5s over here, I'm going to end up with a negative coefficient. There's nothing wrong with negative coefficients. I just know that I have a tendency to make mistakes when I have negative numbers. So I'm going to move these x's over here. And by moving them, I'm saying I have 3 x's over here. I don't want any x's over here. So what's the opposite of having 3 x's? Taking 3 x's away. So I'm going to take 3 x's away from both sides. And when I do that, those x's are going to add together to be 0. I'm going to have nothing left but a positive 10. You can put the plus sign if you want to, but it's not necessary. And a positive 5x and a negative 3x combine together to give me 2 x's. And I still have the plus 7. Now that I do have x's on the right-hand side, I don't want the 7s. Those are constants. I don't want those. So how do I get rid of a positive 7? I stick a negative 7 with it. But what I do to one side, I have to do to the other. So those are going to combine together to give me 0. So when I rewrite this value right here, I'm going to just do 2x. You can put the plus 0 if you want to, but what does plus 0 do? Absolutely nothing. And then 10 minus 7 will give me 3. My x is still not by itself. That's what I mean by solve. I mean isolate the variable. So I'm going to do the opposite of 2 times x. What's the opposite of multiplying by 2? Dividing by 2. So I'm going to divide both sides by 2, and x comes out to be 3 over 2. You can one side of the equation on y1 or on this first line. So we would type in 3 in the parentheses, x plus 2, close the parentheses, and then we'd say plus 4. And then type in the second one down here. We would type in 5x plus 7. And by the way, I put equal. Anytime you don't want to use your keyboard, you can click on this down here, and this opens up another keyboard. And now what you're looking for, since I did 5x plus 7, what you're looking for is where these two lines intersect, where they cross each other. And you're like, well, they don't. I can't see where they do. Desmos, you just drag it down right there. And when you click on that, it'll show you. And it might even, let's see, I'm going to try something. I'm going to go ahead and put the equal sign right there and type in 5x plus 7. And I'm going to turn that off. No, it didn't tell me. Sometimes it would, well, yes, it's okay. So these two where they intersect, let me turn that one back on. That right there, 1.5, you may be thinking, hey, that's not what we got. What did we get? We got 3 divided by 2. But when you type in 3 divided by 2 on the Desmos thing, it comes out and it tells you that it's 1.5. So you can see that the x value from where they intersect right there is 1.5. And isn't that what we're finding? We're finding x. X is equal to 1.5. You may be going, well, what's the value of y? It's not necessary in this problem, because did our problem have any y values in it? Nope, our problem did not have any y values. So we were only interested in the x values, and our x was 3 over 2, or 1/2. All right, so this video ran way long, so I'm going to stop it before I finish the exercise.